we're going to talk about functions, either custom functions that you create yourself or using standard library functions, such as the math library, and you can import math and then use things like square root, or you can create your own function as shown here to take the square of a number. So let's go through this with a couple example exercises. If you'd like to follow along with this, you can go to the notebook for this. Just go to APMonitor.com/CIT263 and then come down here to schedule. This is going to be homework number 2, and you can follow along if you just select this link CL2, and it'll open up a Colab notebook that you can run right through your browser. So let's go ahead and get started with this. We have these problems here where we want to be able to evaluate cosine of x for 0.5 radians, and then also for sine of x with 30 degrees. So we're going to use the math library for this, and we can just see the help for the math library if we do something like import math, and then we do help math. Okay, it gives us some help for all of the different functions that are available. So let's just go down and see if we can find the very first one, which is going to be cosine. And it says return the cosine of x measured in radians. So we can't use degrees in that function, we have to use radians, so that becomes easy for the very first one. And so if I just print, and I'm going to do cosine of 0.5, this is going to be the solution to the first one. Let me put it in the math there, and I'll just include the, I've already imported math, import math. Okay, but if you just want to use import all of the math functions without having to type math, you can do this. You can do from math import star, and then that allows you to just use cosine. I don't recommend this because it clutters your namespace. If you have other packages that you're importing as well, there might be some conflicts with that, such as NumPy is going to have cosine as well. So if you do that for NumPy and math, you don't necessarily know which library you're using. So I would recommend just doing import math, and then just showing that you have math.cosine. And if you're going to use NumPy as well, okay, you can shorten the name like as NP, and then we could just take this line right above it and then just replace just replace this one with np.cosine. Okay, and that should give us the same answer for both of them. Okay, so you can use different libraries. That's how you import a library and are able to use some of the functions. So let's do the second one now. We're going to go ahead and insert a new cell below. Okay, so if we go to insert cell below, and now I can do the second problem, which is the sine of 30 degrees. And one of the things that I can use is np dot degrees to radians. Okay, so let's just see if there's a help on that. Okay, so this one is going to let's see, a little bit of help there. Let me scroll down so we can see this just a little bit better. Okay, so it gives you the degrees to radians conversion. Okay, and so let's do that for sine. I'm going to go ahead and print a formatted string here. Okay, so this one is going to be print, and I'll do F, okay, for a formatted string. The result of sine of 30 degrees is, and then I'll put some curly brackets in here, and I'll do np sine, and I'll do np degrees to radians, and then inside that I'll do 30. Okay, so the result of sine of 30 degrees is 0.5. You can see just there's some machine precision, just how it does the calculation. It's not going to give you exactly 0.5. Okay, there is the second example. Let's go on to the third one here. This is going to be factorial. Now this one, you might need to go look for it. I just printed out the help here on the right. If I scroll down, I'm going to go look for factorial. So here it is right here. Just return the factorial of a number. Okay, so let's go ahead and use that one in our in this as well in a new cell. I'll just go ahead and do. You can do either Control Enter, or you can do. You can also insert a cell automatically below when you run it. I believe that is a control. Let's see if I can figure this out. Okay, it'll just go to the next one if you do Shift Enter, and if there's you can go on to the next one. Okay, so let's go ahead and just print factorial of 25. Okay, so let's see, 5 factorial is, and then I'll end this string, put in my curly brackets, and that one's going to be math.factorial 25. Okay, so that's a very, 25 factorial. Okay, is this very large number right there. Okay, so let's do the next one, which is 4.99, largest integer less than or equal to x. So for some functions, you may not even know what the function is going to be called, and so what we want to do is maybe just go and take a look at sites like Stack Overflow. So if we say, how do you get the largest, okay, let's just look at the largest integer less than or equal to x. Largest integer less than or equal to x, and we'll just ask it for Python. Okay, so here's a Stack Overflow question, and it'll give you the question, and if you scroll down you can look for the accepted answer, and then here is the ceiling function, or you can use the floor function as well. Okay, so let's go ahead and use the either the ceiling -1, or you can use the floor function. Okay, I'll go ahead and insert another cell below, and I'll just go ahead and print math.floor and 4.999. Okay, and that'll give us the floor function is recommended in that Stack Overflow. You can also use the ceiling function, and that'll round it up, and then you just subtract 1. And that'll also give you the same answer. Okay, so there are some built-in functions. So what we want to talk about next is, maybe the function doesn't exist. We need to define a custom function, or we want to do something slightly different than one of the built-in functions. So we're going to use a custom function by using the DEF, where we define a new function, and then we have our function name, which is in blue here. And then we're going to have our input arguments that are going to be here inside the parentheses. And then inside the function, we'll do the calculations. You need to make sure this is indented. So Python has very strict indentation rules. So if something's indented, then it means it's part of this function. And then as soon as you do not indent, such as this print statement, it means that it's not part of that function. In this case, we're going to print the result of the function, which is inputting a value of 2. We will insert a value of 2 here for x. It'll then return 2 squared, and then that will be equal to 4. And then for the next one, we're going to evaluate that again with 4 here, and that's going to be 4 squared, and that's going to be 16. Okay, so let's let's create a custom function and just a couple other things that I wanted to tell you about custom functions as well. Let me go ahead and just insert something right below this, and when you're defining these functions, let's just do return x squared, okay, and then we'll print my function, and we'll do 3. Okay, so we just square the value of 3. But one of the things that we can do is have some optional values. So maybe m equals, maybe the maximum value you want to return is maybe going to be equal to 10. Okay, and so you can add another input to that, and also give it a default value if you don't have the user change it. So here I'm just going to say y equals x squared, and then if y is greater than m, okay, then we'll say that y equals m. So we've just limited it to upper value of 10, and then we'll return y instead of instead of the x squared. So then if I do something like 2 here, it's going to give me 4, but if I put in 4, that's going to be 16, but it's going to limit it to 10. But let's say I want to change the upper limit to 15. Okay, so I could just do 15 instead, okay, or I could say m equals 15. Okay, so be explicit. If you're going to get those out of order, then you need to be explicit about which parameter you want to change. Okay, alright, so there's a little bit about functions, how to create default values, how to return the values from the function. And so let's go on down to these examples here where we're going to evaluate these values at a range of inputs that are going to be given by the linearly spaced values, linspace, in NumPy. Okay, these are going to be our input values between 2 and 5. And we want to evaluate the tangent of pi over x with pi over x in radians. And then we'll do the next one and go on down. Okay, so let's go ahead and also, as with each of these, we'll create a plot of the function value versus the x values. So let's create our very first one. I'm going to import NumPy as np, and then just create this np linspace between 2 and 5. And if I just print x, I can see I'm going between 2 and 5 with these 50 linearly spaced values between them. I could put that down to 20, for example, if I only wanted 20 values. Okay, so let's go ahead and just evaluate the very first one. I could just do y equals and then math tangent of let's do np.pi. Okay, I could also just use NumPy for all of this. Okay, np.pi divided by x. Okay, and then if I wanted to plot this, then I would, I'll just create it right down here. I think when I'm zoomed in, it jumps around a little bit more. Okay, and then I'll do matplotlib inline and import matplotlib.pyplot as plt, and then I'll just plot x and y. Okay, so it's going to give me a very large value here, and right where x equals 2. So if I wanted to create a custom function, maybe to limit the value of the output, I can do this if I just want the raw function, but let's say I wanted to customize that now. And so let's just define a new function that I'm just going to call f, and we'll have our input x, And so you could just return. Okay, we'll just start with this. I'll just say y equals this and return y. Okay, and so this is, you know, I could then evaluate this. Okay, f of x. That's going to give me an error because now it's no longer vectorized. Okay, so what I need to do is then create a loop, and let's just define something here. N equals, we'll do 100 points, and then we'll create a loop for I in range. For I in range n. So it's going to go through this loop 100 times and evaluate the value of this f of x that's going to be returned. And I'll say that I'll just call this z is going to be np, and I'll do empty 100. So I'm going to create a vector of 100 values, and then this is going to be our result. Z I is going to be equal to f of xi. So I'm going to cycle through each of the x's and assign, evaluate that function, and then evaluate z. Okay, so here is my z value. I need to run this one first, and then I can run this one below it, and then I get the same one. But let's say I wanted to now in this custom function I can limit the value of y. So maybe I said the max equals 100, and then I could say y equals max of, I'll do min of m comma y. So it's going to give an upper limit to y, and if I run this one again and then run the plot, then you're going to be able to see, I'm going to just clip off that very first point, and then it's going to limit it to 100 and then come down. So it's easier to see the function here. Or what you could do is, instead of doing this where you clip it at 100, it's going to give you a false representation of what that function is. You could also do something like if y is greater than m, then y equals not a number. Okay, and then it won't even show on the plot. Let's do that one more time, and then it'll just skip that point right there that was at 100 and gave a false indication of what that tangent function would be. Okay, so the very first point that it evaluates is going to be there. The result is about 43. Okay, so here's a custom function that we created. Let's do the same thing for the other ones as well. I'll just replace what's inside this function. We'll reevaluate it and replot it again. So now we'll do the maximum of all of these numbers. Let me just zoom in a little bit there. Okay, so we're going to do the maximum of all of those and return values between 0 and 10. So the very first thing I'll do is come back into my linspace and just modify that between 0 and 10 for these. Let me put the n there. That should be n. And then I can get rid of this max. Alright, and then I could do something like max and then 2 times square root of x, and x squared divided by 2, x cubed divided by 3, and then the final one, x squared plus x cubed divided by 5. Alright, I'll go ahead and return y, and let me also substitute this in for n. Alright, and here is my function here. Alright, so it's going to take the maximum of each of those functions, and this is the combined function evaluated between 0 and 10. Alright, let's go on to the next one now, which is x squared when x is less than 1, but then we'll use sine when of this pi x divided by 2 when x is greater than or equal to 1. I'm just going to replace what's inside this function. Okay, but I'll put if x is less than 1, then we'll say that y equals x squared. Else, we'll say that y equals, and we'll do the sign of np.pi times x divided by 2. Okay, and there's our results, and this one goes between 0 and 10, so you can see that when it's less than 1, it's going to be you know, this x squared, and then beyond that it's going to be the sign. But I don't think we wanted to go all the way to 10, we just want to go to 2. So let's just change that in our linspace, just evaluate this function between 0 and 2, and then when we plot it, we'll just see the subset of those values that we had before. So it looks a little bit like a shark fin, I guess. Okay, so there's our examples of how to create custom functions. Just to review, we have many built-in functions that are in Python. If those exist, it's better to use them. You know, you don't have to necessarily create your own function and debug it. You know, just use a function that's already there. And then if it doesn't exist or you need to change that function, you can write your own, and you can define that, you know, a custom function however you'd like. You can put optional input arguments there, you know, the defaults for that function that the user can then override. And then we showed how to evaluate that function 100 different times for 100 different values, and then create a plot that shows that function. Okay, so we're all done with this tutorial. Again, if you just go back to the course website, you can find additional tutorials and homework problems here as we're going through these Python tutorials for engineers and scientists. And we're going to go on next, you know, beyond functions and graphs. The next one's going to be solutions to equations.